Hi, so my name is Bill Shin. I'm a Principal Security Solution Architect at AWS. It means I spend my time, most of my time working with customers on privacy, security, risk management, and compliance. I've been part of our HIPAA and Business Associate Agreement and healthcare plan for quite a long time. We started many, many years ago serving healthcare customers in the genomic space, in health imaging, a lot of health use cases. And we'll talk a little bit about the history of Amazon and healthcare and architecting for compliance with HIPAA on Amazon Web Services. I'm joined today, thankfully, by Haddon Bennett, who's a CISO and a pretty good friend at MDON, which is a kind of an all-in AWS customer and a very significant part of the healthcare system in the US. So looking forward to that. What can you expect from this session? We'll do a review of AWS's HIPAA program and our Business Associate Agreement so that you know what is contractually required of you and of us and how to architect for those contractual requirements. We gave this talk last year. Anybody attend that talk last year? Wow, a lot of new healthcare growth. I guess HIPAA is important for somebody around here, so cool. We'll learn about how MDON is architecting for HIPAA requirements and some of the lessons learned that Haddon's experienced as they've moved a significant portion of their architecture into AWS as a highly regulated company. And we'll learn how to architect for key security implementation specifications in HIPAA. And the abstract, as promised, will be a little dialogue between compliance and engineering, because there are people who don't have, they don't go out for beer enough together, really. The lawyers and the engineers and the compliance folks and the DevOps people need to spend a little more time together. And we'll show a little bit how they think at the kind of the top of the legal cycle or the regulatory side, and then how that translates down into engineering, which I think will be kind of fun. So like I mentioned, we've had a strong presence in healthcare and life sciences from the get-go. Great use cases for genomic sequencing, for PACS imaging, for medical exchanges, for healthcare information exchanges, all sorts of integration use cases for HL7, for genomic research, for clinical trials, all sorts of use cases that have been happening for years. In January of 2013, the Omnibus Final Rule was issued by Health and Human Services, which promulgated some additions to the HIPAA and high-tech legislation. What that meant, it changed the definition of business associates and put additional statutory obligations onto business associates. And we used to operate under the conduit context, similar to an ISP. The definition was quite clearly changed, and customers have been asking us to sign business associate addendums or agreements for a little while. Prior to that, we kind of soul-searched internally, built a business associate agreement that was tailored to the nature of a cloud provider. So the ones we'd seen to date at that point had been very much geared at outsourcing arrangements, at co-location arrangements, or labs, or billing providers for medical providers and payers. And they weren't really tailored to the nature of a cloud provider where we don't access your content. We don't need access to your content to deliver a service to you. And it's a shared responsibility for security. So it's not simply us that by the nature of using us, you're magically HIPAA compliant. There's work on both sides, and the agreement is tailored to that. We started signing them in about Q2 of 2013 after a fairly extensive pilot process with a number of university hospitals, with large payers, providers, insurers of the medical community. And the program is based very solidly on shared responsibility. We have a HIPAA white paper. We re-updated in about July. It talks in depth about how to use the services that we consider eligible services in a way that has your responsibility and dictates ours a bit as well. We've aligned our HIPAA program and then the services that we make eligible to FedRAMP, our FedRAMP authorizations. It's a very comprehensive audit of a service against the control framework that's stipulated in FedRAMP or FISMA, moderate controls. And so we look at testing all of our underlying infrastructure controls against that FedRAMP set of requirements before we make a service eligible for use for processing, storing, or transmitting PHI. And that's to be kind of customer obsessed in a way, that if you were ever audited, if there was ever a breach investigation, if there's ever a need to demonstrate your compliance to HIPAA or alignment to HIPAA by just using our services, the portions of the controls that belong to us, physical data center, the operations and policies and procedures of our organization, all of the parts of the security rule, we align that to our NIST 853 audits by our third-party assessment organizations pursuant to FedRAMP. Health and Human Services was also our first sponsoring agency for our FedRAMP ATO. And I think that's telling of how we've approached this. Why does this alignment work? So NIST, the National Institute for, or National, the NIST organization that publishes the 853 baselines, they actually also published a document called NIST 866, which maps the HIPAA Security Rule directly to the FedRAMP controls, or the FISMA controls in 853. So that's a very tight story if you're actually demonstrating and reusing controls across your organization. Not a lot of organizations actually, they have a HIPAA security program, but ones that operate at scale and have very mature security programs are usually aligned to NIST or ISO or something like that, and it's a much broader set of controls, and they're able to reuse what they're already doing for control attestation to demonstrate compliance with HIPAA. We've done the same thing. So a little update. This slide may look like the one from last year, because it is. Customers may use all services within a HIPAA account. If you've seen our business associate agreement, it says you may only use these eligible services for processing, storing, or transmitting PHI. It's very explicitly worded, because those are the ones that we want, you're permitted to put PHI into. You can still use all the other services. So you can use, you have to use IAM. You have to use, VPC, arguably, if you're in VPC. You can use, CloudTrail and Route 53 and all those things that are just orchestration. So OpsWorks, Elastic Beanstalk, Kinesis, a lot of things you can use not in the context of PHI. But where it comes to PHI, these were the eligible services that we had last year. So EC2, EBS, ELB, and TCP mode, which means you wouldn't terminate TLS, Amazon S3, Glacier, and Redshift. So as of July, we've added Dynamo DB. We've added 2 flavors of RDS, so MySQL and Oracle, as well as Elastic MapReduce. And we've also changed the requirements for how you use ELB. So if you were an early Amazon Business Associate Agreement or HIPAA customer, there was a lot of architecture work to not terminate TLS. We require encryption in transit and at rest ubiquitously for all PHI, even within a VPC. It's one of the contractual requirements. It's also a addressable implementation specification in HIPAA. And we've modified a little bit the ELB configuration, which I'll talk about. So again, you have to encrypt PHI at rest, in transit, and everywhere, which is kind of a step change from where a lot of organizations are on premises, where they're not necessarily encrypting at rest. They've addressed that by saying, oh, it's a private trusted network. But I think we all security people know a little differently, that it's probably better to encrypt that content than to not encrypt it. We make it incredibly simple to do so, using the APIs, using the service endpoints for some of the services that are more service-oriented, where you're just calling an endpoint. And yeah, it's quite simple. We'll talk about that too. Customers have to use dedicated tenancy or dedicated instances for instances that are processing, storing, or transmitting PHI. Again, you can use regular default multi-tenancy for anything else in the same VPC, the same workload that isn't processing PHI, but we require dedicated tenancy. And you have to audit and log, and we'll talk very much in depth about what that means. But basically, we require you to retain access to information about the activity related to PHI in the account. So it's a HIPAA requirement, but it's rather loosely worded in HIPAA, and we want to, if things go wrong, we want to have a shared dialogue about what happened, and it requires, in pursuant to sort of shared responsibility, it does require that you actually log. We don't have access to your content, so if someone's doing a SQL query against a bunch of PHI, or there's web traffic where a session, a doctor accesses PHI and that electronic medical record system is on AWS, you have complete control over logging all that access to PHI. There are circumstances where API activity within AWS is going to move or permit use of PHI as well, and we'll talk about those, but you also have a responsibility to log access to PHI. So just a simple n-tier architecture, left to right, of what it looks like to use AWS in the context of PHI with the eligible services. So, patient, doctor, user of a system that contains PHI. On the left goes through Elastic Load Balancer. PHI represents, or the green flows represent PHI. I can go out to an auto-scaling web tier, just like any other architecture on AWS. There's encryption in transit of those green lines. You terminate TLS on ELB. Again, re-encrypt as you go back to the app tier or the web tier using whatever certificates you feel necessary. A lot of people use self-signed certs. Typically, people go maybe back to another internal ELB, maybe directly to an app tier, and then to a database tier. Very simple, typical n-tier architecture. Totally supported in the BAA. You can also use S3 for persistent storage to back up, or to use it as an object store as part of your application. And use Amazon Glacier with at-rest encryption, the native features in all these products, using KMS or Key Management Service as the encryption key provider, all supported through the use of eligible services. S3 has a bunch of different ways to encrypt. You choose. You can use KMS, customer-supplied keys. You can use server-side encryption. Glacier just encrypts everything for you, and you can use that as well for long-term retention. can replace that whole backend storage tier with a NoSQL store. In this case, the data is encrypted in transit. You're also, in this case, encrypting for the at-rest encryption. You're doing that through the Dynamo client library. We publish in AWS Labs an excellent interface to Dynamo. It's a Java library that does the integration with KMS kind of mostly on your behalf. You specify customer master keys. You dictate what kind of crypto provider and what level of key hierarchy you want. But you get to use Dynamo as a full NoSQL store and you're doing the encryption within the application. Usually field level encryption of some kind. Using it with the eligible services for PHI in conjunction with other services. So in this case, the blue lines represent, in this case, a region, right? The VPC is that blue line around the entire architecture I just described. You can use config, and in fact, you ought to. You can definitely and should be using CloudTrail. You can't avoid using IAM. CloudFormation can be used to orchestrate this entire environment as a change control mechanism, as an audit mechanism. CloudFormation provides, it's a templated language where you can build this entire infrastructure in a text file, deploy the whole thing, and then have an audit trail. You check that into code repository as a way of detecting change to the infrastructure as well. Also, things like orchestration. So monitoring, as long as you're not sending PHI in your logs, which is a bad practice anyway, you're welcome to use CloudWatch. You can use CloudWatch logs for logging system events, for logging metrics and other things. So things go out. And again, the blue lines in this case represent non-PHI. Push those into CloudWatch logs, use metrics, use filters, use dashboards that are already native to that platform. Go in the other direction, for orchestration, pushing your code. You can use, a lot of people use Jenkins or other code push CI/CD pipelines. Code deploy is an excellent alternative to that. You can use code deploy, assuming your code doesn't actually contain, patient records in it. You push those down to your web and app tier, right? So if it does, then we'll have a beer and talk about it. So it's a therapy session at 7. So a quick architecture review of managing PHI and load balanced applications using ELB. This is terminating TLS on EC2, which is the architecture prior to April of this year. TCP only session, so SSL or TLS doesn't get actually terminated. The certificates don't live on the ELB. You're just doing TCP load balancing through the ELB. It contains the PHI in the green lines, but it's within the sort of the wrapper of the datagram at TCP. TCP new connection proxy through ELB. Terminates on HA proxy or Nginx or something like that, where you have your public, your www.yourcompany.com SSL private keys and certificate. Then the PHI comes out of the TLS bubble on that architecture. You have a new TLS session started from the proxy or the other, where the TLS gets terminated layer. That goes back to a web server or an app server or something behind with additional encryption at TLS behind that HA proxy load. So really you had a lot of people put a WAF tier in there too. So you do like Alert Logic and Imperva, Barracuda, something like that in between, terminating TLS at each layer. It's a fine architecture, works great, a lot of flexibility in those products, or HA proxy or Nginx as well. People will stick with that for forever for a bunch of use cases. But now you can go from, you can flatten that out a little bit. We moved internally to allow ELB to be sort of a first-class citizen when it comes to processing, storing, or transmitting PHI. So now TLS actually can terminate on the ELB. You can put your certificates and use the way we manage certs, kind of as a managed service on top of ELB. A new TLS session starts from the back of the ELB and goes down to your web servers using probably self-signed certificates or an internal PKI. So simpler, a little less to maintain, a little more cost-effective. So I'll hand it over to Haddon to share his story about the journey to the cloud for MDON and how they're addressing HIPAA compliance. I'll be right back.
Thanks, Phil.
Yeah, thanks. Thanks for coming. You got the clicker here, yeah. Sorry.
All right. So Bill made it sound easy, right? All you got to do is migrate to Amazon and you're HIPAA compliant, right? So I'll kind of walk you through our journey. So I'm Haddon Bennett, the CISO of MDON. We kind of just tell you who we are. We're about 6,000 people company and growing and acquiring. We service the payers, the providers, the dentals, the labs, et cetera, and we consider ourselves, we are, the single largest financial and administrative health information network in the nation here. So let me put that in English, translate what marketing was trying to say. So when you go to the doctor, when you go to the dentist, when you go to the pharmacy, when you go get your labs done, if you ever wonder how that information gets from from them actually to the insurance companies and the settlement and the payments and all that. That's us. That's our network. So that's in a nutshell. That's who we are. I'll talk a little bit here. So our footprint is, basically we've been doing this for 17 months. Started small, starting to rapidly integrate as we see fit, and we are a all-in cloud as we declared last year this time. So, and we had about 10,000 application deployments thus far, and that grows as we continue to adopt DevOps concepts. So, when I first, let me back up a little bit. When I first came here, I've been here 15 months now, and as a new CISO as well, I'll admit. I was talking to the CIO during the interview process, and he told me he wanted to go to AWS, and I cringed. I was like, oh goodness, healthcare data. I already know healthcare. It's pretty far behind most of the other industries, and I came from financial services. So I started thinking about it, and I was like, this is an excellent challenge. I'm going all in head first here, and I'm going to figure this out. I've always had the mantra, as a security person, you can't say no. I mean, just eliminate that from your vocabulary if you want to be successful and escalate your career. So came on board, and the first thing I did was get the contract that was not signed yet. Started reading it, and I'm like, you must encrypt everything at rest. You must log everything to the nth degree, and then some, and encrypt your logs and store them securely. And you must be in your own private cloud. And it had all these requirements. I'm like, who put this in there? It was actually, that's Amazon's language. And I was thinking somebody on our legal team actually put that in there. So that's when that's when I truly embraced it and said, hey, this is going to work. I mean, they're actually going to help me solve some of these problems. So if I look back in my career in security, I think about the most difficult things I've ever done. So I promise I won't make this an HR exercise and make you raise your hand and participate, but I'll do it just this once. So if you've ever done one of these 9 things and they've been a pain in your butt, raise your hand as a security person. Okay. All right. I'm sure we can all tell a lot of stories. So they're all extremely difficult in a traditional data center for sure. So I kind of came up with like, what are the top issues that I'll call it excuses. I think I saw one of our IT leaders walk in. Doug, are you over there? There he is. So I'll say excuses. I'm going to call it excuses rather than reasons. I've heard, you've all heard this, right? Not enough CPU, memory. I don't know what it's going to impact, as far as performance. We're already running hot, so we can't take your new security control. No test environment. I won't read all these, but you get it. I think you guys could probably add a few more to this. And some of the reasons are legitimate too, right? You got to make money, so you can't take a system down. So I'll walk through just a couple of those 9 examples, 3 specifically. So logging. This should make sense just by saying this is a bad thing. The fact that you actually have to touch 10,000 servers, right? That means that there are going to be errors, right? Because not one person is doing all that work. And that could be any form of your standard SIM device that you're using, or some open source or commercial tool that you're using to actually tell your system to log. So in AWS, it's as simple as you modify your build script for the configuration to where to point the logs, right? And if everybody's using the same AMI and the same scripts, then everybody inherits that, right? So it's easier to roll out overnight. Just got to be ready to consume the logs when it happens. As far as server network impact, I've taken down my share of networks in the past with some of these type projects. With bogging down an already a switch that's overloaded, or firewall that's overloaded, or their server impacted, or whatever it might be. I'm sure you guys have seen some of the same here. And I'll say this is largely unnoticed if you're actually auto-scaling. Now, it is not unnoticed to your CFO, but that's a different story. Just misconfiguration doing manual efforts that I talked about, consistent and compliant config since you automated and tested it. Everything looks the same. You audit the script. Why do I want to go touch every server? I don't need to. I know that every server was built from the same scripts and AMIs. And the result is several months, and I would argue I've had logging projects that extended into years. So ongoing, right? It never really ends. You start with your internet-facing systems, work your way back, or whatever it might be. But the comparison really is several minutes to turn this on. So some of the tools that are in use for that: CloudTrail, CloudFormation, and then S3 for some of our secure storage for logs. Incident investigation. So here's a hot one. If you've ever, I don't know if it's all security people or what, but if you've ever worked incident response, you'll know that you don't automatically have access to servers in the data center, right? I mean, it's something you request during an incident as a security person, and once you do, do you impact the integrity of the server? Are you blowing the investigation to where if it becomes admissible in court or whatever, right? So I came up with one, just like set up an alert on a root login. So that's something in a data center that probably happens a lot, right? But in the traditional data center, in a DevOps model, nobody should be logging in as root. Nobody should be logging in, period. So, and by the way, throw the DevOps thing back at your IT guys that say they use DevOps. Throw it back at them. Like, why are you logging in? You should be able to script it and push out a new one. You don't need to log in, right? So the other thing on the incident investigation, so trying to get logs from the networking team, from the server team, from the storage team, from the database guys. I mean, it's difficult, right? And then you request the logs and they're the wrong logs. Well, I really wanted these, or sometimes they're not available. That can help you or hurt you. And then, but as far as in AWS, you can architect these next 4 run together. So I'll print them all out. But you can automate a task to actually, you see a root log on, quarantine those servers, spin up new instances, and have it automated. And then you have your live forensics copy, or offline, but was just live, that was supposedly compromised what you're investigating, right? Offline. Production's still up and running. It's not compromised. And then you can do your investigation. So I mean that's key, because doing forensics in the data center is a bear. Doing it on employees and laptops is easy. So the result is just time to mitigate, investigate, and just dramatically reduce your incident response time and being able to actually achieve closure to your investigation. The ways you do this through load balancing and pulling servers in and out of groups, essentially, and properly configured security groups to help you do that dynamic set. The last one here is patching. So in your traditional data center, and I've purchased a couple patching tools in the past that are extremely expensive. And with AWS, I mean, you should just follow your standard release cycle, work it in the code, and you don't need a tool to deploy from that standpoint. You're using the standard deployment tool. Patching 10,000 servers. I mean, that's just an example. I mean, I heard a few chuckles. I mean, that's right. I mean, it's almost impossible to stay up with, bottom line, especially when you're handling exceptions and such. Scheduling the reboots, the downtimes, hey, we're doing a freeze because it's the holiday season and everybody's shopping here, or whatever your business is, right? But with this, again, goes back to the DevOps model, continuous deployments. If you're continuing deploying in a DevOps, then you have zero reason why you can't apply my patch and release it in one of your 10 releases for next month, right? So let's see, patch damages server. I mean, I've seen plenty of blue screens in my career, and I'm sure a lot of you guys have as well. And just inability to actually roll back a server is a lot of times like, why do I really want to patch this? Because the server's so unstable. So then you get in a risk management discussion, and when you get in a risk management discussion, you lose, right? I mean, so with this, it's just, hey, redeploy a previous version that's working, right? And then no proper testing environment. That's a good, or I say good, it's a legitimate excuse for not patching often, where, with this, there's actually, take a copy of production, apply it, do your testing, and you shouldn't have a reason not to patch, right? The result of this is really just, stability, being fully tested and compliant at the end of the day. So, so that's really it. Like I said, two things I'll say here. One is jump onto the DevOps process. Some of the DevOps things are unclear to security people in their mind about, all right, so I can't really audit this, or how do I show the separation of duties? Try not to wrap your head around that so much, and look at the actual intent of auditing and change control and separation of duties. And I think you'll find there's actually a guy, if your auditor's E&Y, there's a gentleman at E&Y that has a DevOps talk with online that you can find that I'm happy to share with you, email me, that talks about how to meet the spirit and intent of the rule for SOX auditing or whatever. So embrace the DevOps mindset, and then hold your developers accountable for following it, and don't let it's a fantastic reason for them to have to patch because they're making changes constantly and continuously, right? And then the last thing, it really does speed up your. If you reference back to the 9 things that were difficult, right? I have an ongoing joke with one of our DevOps guys, and talking about encryption. It's like, yeah, all you got to do is check the box, right? And a lot of the things are that simple. Reality of it is so it really just it speeds up your security program tremendously. So that's it, Bill.
Thank you very much. Thanks, Ed. I think it's good to hear from the people that are practicing it. It's good for me to stand up here and say it's possible, but Haddon's leading the way from a security perspective. Really big, complicated organization, and a pretty big AWS customer, so thanks. So this is where we get the compliance people and the lawyers having beers with the engineers, right? So maybe not yet, but maybe later tonight. So if you've never had the joy of reading the Code of Federal Regulations, HIPAA is actually part of Title 45 CFR part, or Code of Federal Regulations Part 160. Specifically subparts A and C. This won't be boring for long. So the Code of Federal Regulations, CFR, talks about a lot of things, right? So there's actually, let's see, Title 14, Chapter 5, Part 1, or 1217.106 says that stuff brought back into the US from space doesn't have to go through customs, right? Which is awesome. So it's very specific, though. Things in space, US, no customs, right? So very specific, measurable, can operate to it. This one's pretty cool, too. So this is the St. Lawrence Waterway. And specifically, some regulation, subpart A, 40110, paragraph 2, states that mooring lines on vessels in the waterway have a diameter not greater than 28 millimeters for wire and not greater than 64 millimeters for approved synthetic lines. Okay, so I don't care about the St. Lawrence Waterway at all, right? But it's interesting that the legislation of our country gets that specific, right? Wouldn't that be, that might be awesome for HIPAA. I'm not 100% sure. But it's that's clear, right? And so I think if you look at things like, public welfare, Title 45, subpart A, health and human services, right? This is where, now we start to see where compliance people and regulatory people kind of play. So CISO's probably at this level as well. Part 160 is general administrative requirements. Part 164 is security and privacy. There's a little bit of the security rule in both of those. Subpart C, security standards for protection of EPHI. Now we're talking like InfoSec, right? So you start to get more architects. The 4 parts of the security rule, administrative, physical, technical, and organizational safeguards, still don't have anything I can engineer to, right? 312B2, audit controls. Okay, now I know where I'm at if I'm in charge of SIM or in charge of logging or building an app and I want to log stuff. Let me go back to that for one sec. So it's deriving engineering from regulation is the point here, right? So how do we get from Title 45 down to something you can actually implement? So I'll take a second. I hate to read slides. Basically says audit stuff. Record and examine activity that contain or use PHI. Still, not real specific. I mean, you can build to that probably. We also take a very close look at the Office of Civil Rights Audit Protocol when they would audit business associates for should HHS come knocking. Pretty good standard. It's basically the audit work papers would be generated from this, and the field work would be examining key activities, and they're documented publicly on HHS for each of the things that would be tracked or for each of the things that would be examined. They look at key activities. So determine, for this one specifically, determine the activities that will be tracked or audited. Okay, that's something you got to do. Inquire of management, whether they're implemented. And then there's also another key activity of selecting tools and actually doing system activity reviews. Okay, that's still more text than an engineer is probably likely to read. Something you have to do, right? Determine the activities, document them, and determine whether the controls have been implemented. Okay, so I can determine the activities. That's pretty geeky, right? Also select tools, do the activity reviews, document the process, and capture the audit information. Those are actual activities that I think you can start to engineer to. So we'll start with this one. Something you have to do, determine the activities. Now, in the application space, we'll talk about that a little bit, but with regard to AWS and architecting for HIPAA compliance in AWS, we'll scope it down to that. So there are things in our platform that would affect the movement's potential use or potential disclosure of PHI. So attaching a volume, an EBS elastic block storage volume, to an instance, if that instance has PHI on it, and that you have a grant to the key that's encrypting it, for example, that could move some PHI. Someone could, in an unauthorized or authorized way, attach an instance containing a bunch of PHI to an EC2 volume. So that's an audit trail, right? That exists in CloudTrail today, and it's an event that you should be monitoring for. Combine that with EC2 metadata, like or attributes, so tags on instances or tags on EBS volumes that might have PHI, a label of that instance or that EBS volume, becomes a very powerful audit tool for security practitioners. All the time you're getting an audit log of kind of what's happening. A few others. This one's debatable. Security group ingress, which is an API call opening up a security group or a firewall rule. If there's no authentication on a service that you're opening up, that's a potential avenue to systems containing PHI. You ought to have authentication too. Copying a snapshot, you can share that out to another account in some cases. You can copy it across regions. Those are all good things. They're great functionality, but if they have PHI on it, it's something you ought to be tracking and reviewing that for appropriateness. PHI has to be maintained. If it's the true source of a patient record, you need to have a copy of it, and you're accountable for that legally. So, deleting snapshots, deleting volumes, those are things that potentially have an impact. They might not, but they might. So, tagging your instances, tagging your volumes, and looking at those activities. S3, similar kind of audit trails. So, not talking about SQL authentication or DML, DDL up in the database space. Talking about the things that are AWS related. So opening up a port to the RDS instance, copying snapshots, deleting snapshots, modifying the instance in some way as to change the security profile of that instance. Amazon Glacier, deleting an archive, deleting a vault. If you're using Glacier for your long-term retention of healthcare records, awesome use case, super cheap, extremely durable, encrypted, global. But if you delete the archive, that should be something that's in accordance with your retention schedule. And in accordance with consent and other things around patient rights. Deleting tables in Dynamo and update tables. Those update table could affect the streams that you're using to log the actual writes and updates and puts and things into Dynamo. So that's more of the DDL of Dynamo. Redshift, that's a data warehouse. It's part of the BAA, but deleting the cluster, opening up the rules to the cluster, turning off logging. Again, that's probably not going to affect PHI directly, but it's a key control. It's part of operating an effective control is having logging on Redshift. So if someone's disabling logging, they might be disabling logging for the actual activity in the database tables themselves that could contain PHI. CloudTrail events. So it's kind of meta. A little bit, but if you're relying on CloudTrail for all these other events, and someone goes and deletes the trail or disables the trail or changes the bucket to one that doesn't exist or something like that, that sucks. And you should know about it. You will see these events. As sort of the last breath of CloudTrail. You also will have. You should have very, very confined identity and access management policies on CloudTrail so that no one can do this except the root account or maybe a very privileged IAM user or something like that. But really, you want to watch for these as well. And you're not going to be looking through logs with grep, right? And we'll get to something on Better Life in a second. So S3 CloudTrail events. We integrated S3 with CloudTrail, which is one of the last big ones to get onboarded in September. Delete bucket, these are just HTTP gets and puts, but putting a bucket policy, changing the life cycle if that's something you're dependent on for long-term retention of electronic health records. Those have potential impact, maybe not quite so much. Tagging, that's if you're tagging your buckets and someone's modifying the tags, similar to EC2 or EBS, then you want to know if someone's changing the tags, especially if you're making compliance decisions based on those tags. Cool. So determining the activities, these are things up in your portion of the stack though, right? So we're moving a little bit higher up in the stack. The shared responsibility here is now in the user or the AWS account holder's control or destiny, if you will. So obviously var log messages, var audit, Windows event log, var log whatever for your app. When you're writing your applications, in Java or Python or whatever you're writing in, log out the activity related to PHI without logging the PHI itself, right? That should be fairly obvious. Not always entirely possible to scrub the logs completely. That's another thing to kind of put on the risk register, but essentially, wherever you put your logs, that should include some indicator of access to patient content, right? EMRs do this. There's a lot of need to do this in most healthcare applications in a sensitive way where it doesn't actually log out the PHI. So a record ID that's totally different from any of the PHI, or something that indicates which records were accessed, so that if there's some sort of investigation, or you need to know someone was or wasn't appropriately accessing content, the scope. It's a big difference to say someone accessed 10 records or 100 records versus 50,000 or 1 million records, and knowing either a count or something that tells you kind of what was accessed. RDS, it's a managed database platform, but you still have a lot of access to the parameters that database administrators want the most. So with RDS, most DBAs were spending a lot of time keeping the database alive, and less time optimizing queries, less time being a database administrator. But they still wanted more kind of the knobs and dials and things they're used to having when they're running a database platform on either EC2 directly or on premises. So things like logging, they want to be able to control. For MySQL, and Oracle is slightly different, but there's DDL and DML, so data definition, data manipulation of the actual create table, modify a column, something like that, or actually select and update, set, insert, those kind of things are all in the MySQL logs. You can turn on general logging. It's performance impact, of course, but it's good to have the log and just account for that in your scaling and your capacity planning. The log output, you can put that into a table or a file and get at it through either the direct, it'll put it up into its own table, or you can use the RDS APIs to get the log files out of RDS in kind of a rotating fashion. Redshift has extremely detailed logging, several different kinds that are relevant here. Connection logging tells you, where the connection came from, and query text logging, if you enable it, does give the full query text, which is pretty awesome for optimization as well as for knowing who ran what query. A lot of times it's enough just to log the queries, so you don't necessarily have to log a result set. But logging the actual query that was run, and then being able to do some kind of journaling or change detection of what the records were at the time, and determine, at the time the query was run, this is what the result set would have been, would give you a clean record of who accessed what PHI. So definitely good things you can enable. Dynamo DB has application level events that come through. You either get them through the SDK. When you're using the SDK as a client to Dynamo, and that's basically your database provider, you could log it there, sort of in your data abstraction layer. Or you can log it with Dynamo DB streams that would send streams of changed columns or items, rather, to wherever you're sending the stream, like Kinesis or something like that. So obviously being careful not to put PHI in those, but it would tell you when someone does a put item or get item or something like that. So documenting all this, right? So we talked about what events we're going to do. We're going to determine whether audit controls have been implemented. So CloudTrail, right? How do I know that CloudTrail is turned on since we're so heavily dependent on it? And how do I document that? I think the modern state of auditing, right? If you're an engineer, or if you're an auditor, no offense, the modern state of auditing, the work papers and the field work that's done is still a lot of screenshots, still a lot of observations, still a lot of file folders, sometimes manila, where the evidence and the artifacts of an audit are not really kind of cool with DevOps and API calls and things like that, right? So, but this could be a document. You could literally print this out, like if you had to and you were compelled to. You could print this out to show the state that CloudTrail was enabled, it was for each region, going to the right bucket, and that it's turned on. Right? And I think ultimately, there's more of a DevOps mindset around audit and compliance these days, and hopefully, this is going into some sort of output. You can make the API call anytime to get run it every 5 minutes, right? Or use AWS config, which also supports CloudTrail to detect time series changes to the CloudTrail configuration itself, and then use the output of config to use that as your audit artifact, right? If you're asked, how do you know logging's enabled? This says logging's enabled to the platform level across AWS, and that's kind of how you prove it. You can also do this through Trusted Advisor. So I think this might be, I think it's one of the free checks, I hope it is, that you don't need support for. So being able to just run a report and get across the entire planet a sense of whether your platform level logging is turned on. So compare and contrast that with a traditional environment, right? In a data center environment, you have load balancers and switches and SAN fabrics and fiber channel switches and firewalls, and all these things have different logging formats. They all often have different silos of the organization maintaining them. And all that same stuff, that platform level infrastructure stuff, is logged in CloudTrail in one format, request and response to one place, and it's global, and it's quite easy to turn on. So you could use this for security metrics, you can use this to cut tickets, to go tell somebody to fix it. And so basically, you could use this report as a way of demonstrating that at least some portion of 312b2 is engineered properly. So a compliance person might get this, right? And a legal person said, look, we've got logging, there'd be a little bit of an explanation, but I think the evidence is very much right there. So I'm diving into these particular, like one or two of these things. I won't go through every part of the HIPAA Security Rule. We'd be here probably till next week. But the point being is that this is an exercise that's worth conducting, maybe once, right? Where you go down and go through the stack and look at how that regulation and the compliance guidance and audit protocols are going to be interpreted by engineers. If you're a compliance person, spend a day next to a developer who's got to live this stuff. If you're a developer, spend some time with your compliance people and say, like, look, this is what you normally see. It's high up on the little small font thing I did earlier, but this is how I see it. This is, this is an API call. This is how I instrument this. It's a really valuable exercise. So what else? Something you have to do, select the tools, activity reviews, documentation, and capture the audit artifacts. This will be very AWS-centric. There are a million ways to do this. But I think we have a great architecture for this. I think it's extremely compelling. There's not PHI involved in this activity, right? If there's not, this architecture works great. You have EC2 instances with CloudWatch logs as a logging agent that sits in the instance and can forward to CloudWatch logs for any arbitrary log you want, var messages or var audit, or your application logs. You have CloudTrail that also, a lot of people from CloudTrail's history just put it in S3, which works, and you pull it in with something like Splunk or Sumo. Also, before reInvent last year, it's one of the services that launched right before reInvent, so nobody saw it in the keynote and promptly forgot about it. The CloudTrail directly integrates with CloudWatch logs, so you can just point that as a destination for your CloudWatch logs, or for your CloudTrail logs, which puts it in a logging platform that's infinitely scalable as far as logs are concerned. We also, earlier this year, announced CloudWatch logs subscriptions, which basically you use the CLI and you say, I'm going to subscribe this log group to a Kinesis stream. And from there, there's actually in AWS Labs, there's also a CloudFormation template that sets up a CloudWatch log subscription consumer. It's a piece of code that somebody at AWS wrote that is consuming the Kinesis stream with the client library, the Kinesis client library. So it uses the Kinesis APIs, basically near real-time feed of the CloudWatch logs through Kinesis subscription, and then the CloudWatch consumer is eating off that stream and parsing those logs and putting it directly into Elasticsearch. And that all runs on an instance. If you want to do that, actually runs the whole Elk stack, which is Elasticsearch, Logstash, and Kibana. And it deployed the CloudFormation template. It kind of deploys that, right? You still have some infrastructure to manage there after the template's been run all the way on your right, which is just that instance. But if you think about this from a traditional IT perspective, there is zero infrastructure at all until you get to the Elk stack minus your EC2 instances, right? So CloudTrail, all the platform logging, no infrastructure, all the way to a search tool with no infrastructure to maintain. So a security analyst could be a security analyst and doesn't have to be a sysadmin, doesn't have to be maintaining infrastructure. It's quite powerful. What this looks like a little bit more between CloudWatch logs and Kinesis, and this is a good pattern for any logging, let alone PHI or activity logging for HIPAA. But you have you can subscribe it at the log group level. So in this case, I've got 3 log groups there: a log group CloudTrail, CloudWatch log syslog, CloudWatch logs custom, and each one of those has one or more streams within that CloudWatch logs group. Those go into Kinesis through a subscription that you set up. And again, we have to document this, right? This is a regulatory compliance effort, right? It's engineering, but you also have to prove it, right? So kind of the last mile of engineering for compliance is this is the output of described log groups, right? So that log group, you name it by name or have a prefix. And it shows you the evidence of where it's subscribed to, the time it was created, and that it's actually operating effectively. Same thing for the subscription filters. So I have a filter that sends all of the subscriptions and filters those down. You can set filters on them too to send less of the logs, but basically the documentation becomes the ARN of that subscription to show that it's operating effectively. Now we have to do the activity reviews. So based on all those event logs that we've talked about before, it's pretty simple to set up Kibana or Splunk or Sumo or any logging platform, search platform. This is an arbitrary example. I don't really have my own medical, I don't have a hospital. So I've used describe API calls as just examples. I took describes out of the log messages I was showing before, but anything like delete or update or attach or any of the event API calls that we've talked about before, you can set up searches in Kibana. I've set up a little dashboard where I've put the regulation in there and put the audit protocol specification and kind of the control language, and then actual evidence of that control right below it. And I think that's, I'd love to hear other ways that this is being done, but I think this, this provides a very compelling way to say, look, I'm reviewing these, and you can have searches set up, you can have alerts set up, you can push these into workflow systems like ticketing, or case management, or governance, risk, and compliance tools, and you have kind of, the count is sort of made up, but like it's 618 events that could potentially have PHI-related events. I mean, that's all the describe calls I was doing as a demo. But if you're having dashboards for each kind of service or each application, I think it's a very powerful way for security and development engineering to sort of take accountability for reviewing the events in their application that have to do with PHI, or you could give this as evidence to the compliance and regulatory folks as well. So, like all things at Amazon, I turned these in, and then they were promptly made obsolete by something we launched. So I did have time I was like, I kind of went through this, and I'm like, this is awesome, but it's still, it's some work, got some moving parts. So let me take a few moving parts out, I think. So we launched last week, another service that launched before reInvent was Managed Elasticsearch, or Amazon Elasticsearch Service, which actually takes care of the last half of whatever I just told you about. So you can do both architectures, and both have different trade-offs to some extent. I mean, the Kinesis Client Library is kind of sweet. There's some additional configuration you can do. But you can literally go from CloudWatch logs, and now you can instead of going through Kinesis, which it does probably at some point work with, but CloudWatch logs directly, you can subscribe directly to Amazon Elasticsearch service. And then there's actually a managed Kibana instance as part of that offering too, which means that the CloudFormation template I talked about builds the cluster for Elasticsearch. But it doesn't scale it for you necessarily, right? Amazon Elasticsearch Service scales the Elasticsearch cluster. You don't need Logstash as part of this because CloudWatch Logs goes directly to it. You don't have to maintain services or web services, web headings for Kibana. It's all part of the managed Elasticsearch service. So I think it's a big win for folks in the regulatory compliance space. So I won't walk you all the way back from the top, but we will talk about encryption. Going back to 164.3.12, so the technical safeguards. Where does encryption sit? It sits at 312A2. So encryption and decryption for really the at rest, and then the in transit is part of the network, the transmission security stuff a little bit lower down. I put these in fine point kind of just for effect, really. It is actually literally fine print. Like if you read the CFR, it's very, very small. But the point being is that it kind of takes, how many licks does it take to get to something you can engineer to, right? And you see the encryption requirements are kind of buried down in there. And they're addressable, which means that you got to address them, and you can't not do something about it. You have to address it with risk mitigations or control, compensating controls of some kind. But in the case of Amazon, it's required. It's easy, and if you look again at the audit protocol, or the actual statement, sorry, it just means implement a mechanism to encrypt and decrypt ePHI. That's the one for at-rest encryption. The transmission one's similar. And then there's this thing that HHS publishes, which is the guidance to render unsecured, protected health information unusable, unreadable, or indecipherable to unauthorized individuals at that link. And that's kind of the more prescriptive guidance. We'll take a look at that. It basically says it's a screenshot. That's like the page. That's what you get as an engineer, right? So it says, it broadly says, do something to encrypt your content. Break it down a little bit and highlight some words. Has to be encrypted with an algorithm process, confidential processor key. Decryption tools should be stored on a device or a location separate from the data they're used to encrypt or decrypt. Most people think tools, in this case, applies to the key, so store the key separately from where the data is or where they're used to decrypt or encrypt. I'm going to kind of raise the bar a little bit and take that out, right? The process should not be confidential, right? The key should be confidential, as says this guy who's Mr. Kirchhoff. I think he's an Austrian or maybe a Dutchman. Basically, he wrote a journal article in the 1800s for military science, and he was talking about secret encryption or secret messages for military use cases. Basically, he said the system must not require secrecy and can be stolen by the enemy without causing trouble. That was, it's like the 6 principles of cryptography and secret messaging from like a long, long time ago. And if you have mutton chops, it sounds awesome when you say it. So it's one of the key, it's the key principle of key management and securing the key, not securing the system or the algorithm. That's why all the algorithms are public. I kind of disagree with the fact of a confidential process. Having a confidential key and having the key stored separately is pretty much essential to having a robust application of cryptography for PHI. So we look at the OCR Audit Protocol. What do they look for? They are pretty prescriptive here. Types of encryption used has to be documented. How the keys are protected. Access to modify, create keys is restricted to appropriate personnel, and how the keys are managed. Those are what they're looking for in the audits. That's what most of your auditors and compliance folks are looking for as well. Straight in the wheelhouse of KMS and other crypto services that you can procure from the marketplace, SafeNet, Trend Micro, et cetera. We really think key management system or key management service has really addressed these particular key activities, and it's easy to document them. So as you look at KMS, or as you look at Amazon services that are eligible, we have integration. KMS, or Key Management Service, was launched last year. reinvent has been in use by Elastic Block Storage prior to that in March of 2014. It integrates natively with these eligible services, right? So Elastic Block Storage, and I'll describe this in a second. Database service in Oracle for MySQL and Oracle. S3 with SSEK, or customer managed keys with server-side encryption. You set the object in a put. You specify the master key. We created object key encrypted to the master key, store the object. Redshift, you could encrypt the cluster keys to KMS. And then MapReduce with client-side Elastic MapReduce file system and some other bootstrapping actions can be used to encrypt all of the data everywhere in EMR. So scratch files on local ephemeral disk, data replication between Hadoop nodes or HDFS nodes. So great integrations. It's all there. There's probably no cost to any of it either unless you go beyond the default keys. Quick description of this. There's lots of talks either I've given or Ken Beer has given on EBS volume encryption, but just a quick kind of refresher of how to address the audit protocol and how to address the idea that you keep the keys separate from where the data is being encrypted. So when you encrypt an EBS volume, or you create an EBS volume rather, and you say I want to encrypt that volume, we create a unique volume encryption key generated out of KMS. It encrypts the EBS volume. The customer, it basically, whenever you call KMS to generate a data key, we hand you back an encrypted copy of the key and a plain text copy of the key, right? You use the plain text copy of the key in your application, or in this case, EBS as a service uses it to encrypt the volume, and then it just purges the plain text version of that key, and then keeps the ciphertext copy of your key and stores it. It can store it anywhere. It can store it on the internet for anybody cares. It's encrypted to the KMS master key that never leaves KMS. So to separate out the keys that are used for decryption from where the encryption is happening, the plain text copy is in memory at most. It's used to encrypt the data at rest, and then the encrypted copy of the volume key can be stored with the volume essentially. So then if you take a snapshot, it's also encrypted to the same key. If you replicate this to another region through EBS volume snapshots, it's actually encrypted to, there's a process to actually copy the snapshot and encrypt that to a customer master key from a different region because keys are not exported across regions. So one other thing I think is important about encryption is the ability to know that you're actually doing it, right? Pretty important. And so one of the things about metadata, can everybody see that, or is it too small? There we go. Is being able to audit your environment, right? So in a traditional environment, you have SAN volumes and NAS and attached disk and all sorts of things. And there's not always a way to know outside of those systems themselves that the data is encrypted. You need to actually go grab the data and see a bunch of gibberish, or you have metadata in maybe a CMDB, or maybe you have some kind of metadata in your stores. But for the most part, all of AWS, the data about the stuff, about the objects, is actually outside of that object or stuff. So metadata from EC2 or EBS gives you a pretty clear indication of whether things are encrypted. So this is using some fairly, I think, kind of crafty CLI switches that a lot of people don't know about. This could be done in the SDK. You can do this with the console. You can do it through command line tools. But basically, I'm doing an EC2 describe instances. No, wait. I got it plugged into a network cable. Good old Ethernet. Not going to happen. Somebody tell a joke. So I'm filtering basically on data classification equals PHI. I get all the volumes that are attached to that instance, and I see the state of those volumes and whether they're encrypted or not. That's like one command line for all of my BS volumes entirely through AWS. I'm going to put it in a table in one region at least. And you can do this for every region, assuming, yeah. So the volume, or the instance has a data classification of PHI on the instance, which means somewhere on that instance I'm processing PHI, like the application. I get the volumes, for each volume attached, or for each volume, I've tagged that volume as well for PHI. And it's either in use or available. So the ones that say in use are attached. And you can see that none of those are encrypted, right? It's kind of for demo purposes. I would encrypt PHI. But the one that's, I've actually set up a new one. So the one that's available and unattached, the encryption is true. And I mean, this scales like infinitely for hundreds or thousands of EBS volumes across each region. And I think it's a really powerful tool. That data is coming from like outside the system. You're not reliant on the drive being attached or someone having access to the operating system to be able to go and see if the agent's running or see if the drives are encrypted. I think it's a very compelling reason to use the APIs effectively. So when Haddon talks about enforcing DevOps, making it security's job, and using the tools for what they're worth, I think that's a pretty simple query, and you can get it's pretty powerful from a perspective of trying to prove that you're actually following HHS guidance, and I think it's rather compelling. So, does everybody use tags? Tags, EC2 tags, EBS tags. Wow. Okay. So this is the EC2 console, right? In Oregon now. I have 18 running instances. I'm going to maybe somewhere the internet. All right. It's totally secure. There's no instances. Yeah. So the point being, if this comes up, let me see if I can get volumes. What? Oh, there we go. Yeah. All right, hold on. So EC2 instances. So these are the servers running in. Come on. Yep, there we go. I've classified my data in some way or another. You could do PHI. You could do any kind of data classification. Public, confidential, limited use. And I've classified them as red or yellow, which gives you that metadata about the instance. You could put PHI in there as well. For the volumes in this case, I've given, you can see whether they're encrypted or not encrypted in the console. Several of them are encrypted. Which key ID they're encrypted to. I've encrypted them to the red key in KMS. And every time that key is used, either by a principal or an actor that's human, or by the EC2 service, to actually attach that volume on your behalf, there's an audit trail of when that key is used in CloudTrail. So the intent of the OCR Audit Protocol is to show when keys are used, who has access to them. You have the IAM policy, the Identity and Access Management policy, on the key, on the volume, and the instance. So you have 3 places where you have to be able to, you can manage access to limit that. And you also have the audit trails in CloudTrail of attaching volume. So it's a complete picture, I think, of how encrypted content is being used. There's tags on each of these, and you can set the arbitrary tags, basically. And here I've tagged this one as having PHI on that particular volume. So please, feel free to hit me up or hit up your local account SA and your sales rep and things like that. There's a white paper about this recently refreshed in July. There's a great healthcare portal on aws.amazon.com. If you look up AWS Healthcare, there's a great landing page for all healthcare. It's got life sciences and other research cases and payer providers, customer use cases and studies, and additional links to other HIPAA documentation like our FAQ that we keep up to date with all the eligible services and other information. So I'd love to hear how you guys are addressing this. It's a feedback loop, so the more you guys share with me, the more I can share with the rest of the AWS community on how to really knock down the HIPAA compliance challenges that customers are having, how to architect for it on AWS. And I appreciate Haddon showing up and telling his story. And thank you very much. Please complete the evaluations. Thank you very much.